We're on live now.
Hi.
Hi everyone. I'm Elaine, head of AI robotics.
Hi, I'm Jenny. Welcome back.
Welcome to our next episode of our live stream. So it's been a month for NVIDIA GTC last month in March in San Jose in US. So although it's been 1 month, but the vibe of the GTC is still ongoing. So we want to have this live stream to share the all excitement we went through at GTC, the cool demos and also projects, and also we get a hackathon directly after the GTC.
That's wonderful.
That went very successfully. Yeah, so Jenny, this is your first time GTC, right?
Yeah, this is my first time attending the GTC in person with our team. And wow, it was massive. Yeah.
Right. So, GTC was blessed. Actually, GTC 2025 is 40% larger than the last year. So for exhibitors, that what I can feel is twice more than last year. So it's more crowded, and also more attendees.
We can see like more and more visitors coming by our booth to see all of the demos and the products. Right. So I think this conference spanned 2 main halls packed with the cutting edge demos and booths from like physical AI, industrial AI, and also healthcare, automotive, data centers, and also like large model AI agents, and also even more the robotics across a wide range of applications. So you still have different topics of sessions to attend every morning, and there was so much to explore and learn.
Right, and we had a chance to connect with a ton of developers and engineers, and we also have our community developers. At least we're already very familiar with their projects, and some people are very active in the Jackson AI Lab. So we finally meet them in person and share their projects. After they have used our robot SO 100 arm, and also they have built their own humanoid robot, and also like Disney BDX robots they show to us. I think it's a very good reunion to us and to meet customers and developers.
It's a great chance to reward the exchange of ideas, and we are grateful for the support and the insights based on the products and also the demos. So Elaine, anything impressed to you for this NVIDIA GTC conference?
Yeah. So first of all, I think GTC to me is the best event to learn the new technology. But this year, last year I didn't get much time to go over the exhibition. But this year, the most time I stopped at is NVIDIA Pavilion. So I am so impressed by the adoption of the NVIDIA in the NVIDIA Pavilion. So and also that is highlighted like agentic AI that highlighted by the Jensen Huang's keynote of the GTC 2025. And I see a lot of agents, examples of the RAG pipeline, agentic AI workflow, including the IT. And what is more exciting, that is, I found NVIDIA has very comprehensive solutions for biomedical research and climate change. They are using the NVIDIA blueprints and the name. So I want to show you there, for example, it's like for this one, there is NVIDIA NIM microservices for NVIDIA Earth 2. It is part of the blueprint, and it is for predicting global atmospheric dynamics of various weather and climate variables. And it can be as accurate as the 1 kilometers in the landscape of Earth. So that is pretty cool, and also it is a comprehensive solutions, and developers can directly experience on the NIM and download the code, and they can even just try on their web page.
Yeah.
Okay. Another takeaways is so besides the agentic AI, the agents, I think the most thing is catch my eyes, physical AI and the robots that is mentioned a lot in the Jensen's keynote, and Jensen highlight many times for their three computers concepts.
Yeah,
three concepts for one computer for training, another for using the Omniverse for simulation, and then is for the deployment for the robots. I think the physical AI, as Jensen mentioned in his keynote, is a 50 trillion opportunity right now. And NVIDIA is obviously leading the way with its software stack, including Isaac and Cosmos platforms, and also its hardware of three computers. And I think embodied AI now is transforming robots and automation and developing across the many different kinds of the robots. Actually, the hardware itself and the software itself is scenario agnostic, but we see a lot robots have been already getting into our life and getting into our workspace. Like manufacturing, and like 1X robot is already in the home. So a one-to-one session is very impressive, and I learned a lot. It's AI for Humanoids by Peter Abbey from UC Berkeley.
Yeah, let's check out the landing page here.
Yeah, so this session is on demand right now, so everyone can check it out right now. Yeah, so in this session, it is mainly Peter mainly talk about now what is the current stage of the building up the humanoid robots, and it can see it's reasonable right now. The humanoid robots can be commercially exist in our life very fast in just a couple of years. But however, he points out the hardware developer is accelerating faster than ever. But right now, the challenge lies in the software, which means it is the robot's brain. So, because 1 second, let me go to.
It's like the robot brain for the hardware, like development.
Right, because the development for the let's say model, although it can be multiple model or it can be one model, but it's the model for the robotics. But the model, the trained robotic model, that is different as a large language model. For the so it's harder, or it cannot get a GPT movement for robotics.
Yeah.
Because there is no equivalent massive data sets like GPT using the Google, YouTube. But for robots, there is no the equivalent massive data for teaching robots how to move and interact with the real world. So Peter points out, but for the robotics, how can we solve the data problem? How can we gather the data? There are different ways. So first, the most used right now with the hardware that is using the teleoperation. You can use the robot arm. You can use even the robot hand, the hand, and also like Aloha, their door arm, and also teleoperation can also combining the chassis like mobile Aloha to do the teleoperation, like through the observation to action. Oh, and also we can use the joystick and also the VR for the teleoperation. And then it can use the robots can learn from human videos, and you can also train in the simulation by using Isaac Sim because if we want to collect the data through the teleoperation, it's tedious. So 50 episodes is okay.
Just the basic one.
But 1,000 that you cannot imagine because that's long time taking. Like each episode, like 2 minutes or 1 to 2 minutes. That's a tedious task.
Yeah.
So simulate can solve this problem. We will also introduce this later. And also we can use reinforcement learning for using the real robot, directly using the real robots. And also we can ask robots to learn from the internet videos or text. Yeah, so but each way has its pros and cons. And Peter pointed out we can use a combined way, like combine this different type of data and then train and learn the neural networks for the robot brain, and then get the fine-tuned on-text reinforcement learning.
Wow, that's impressive.
Yes. So I think we're on the way right now. So we get simulation. We tried a lot. And for the videos, NVIDIA Cosmos, they provided a large, the world's right now the largest data sets for the humanoid for the robots, and also we get many ways for teleoperation using different types of the robot arm. Yeah, so and this is a GROOT. NVIDIA it has the Isaac GROOT N1. That is now the robot's foundation model. It is using based on the combined data, including real world and synthetic, and also the web data of the human videos. And I'm surprised that this one is also using in our hackathons and directly deployed in the SO100 arm. So which means you can directly start it to deploy this model at home. Yeah. So I'm excited so my takeaways for this session is now there's no convergence yet for a standard data for robotics, and there's no the best way to combine the data source. So everyone, so it is in the research. It's in the research state, and the exciting thing is we're together with the researchers and to exploring this, and also through the open source projects. And also another thing is, so we can directly jump into this field even at home. So we can have the low-cost robot arm. We can try a Groot N1, and we can also we can even though you don't have any hardware, you don't have the robot arm, you don't have the humanoid robot, you can start it from the Isaac Sim to using the simulation. Yeah, so I think it's making the threshold a very low barrier, so developers can join, and then researchers are keep going on. So it's exciting to us.
Yeah. It's just a good start to like develop the robotics. We are just in the middle of that, and we collaborate all of the companies and all of the partners to do it together. And I think we mentioned before, like the data collection part, it is the huge, like the big problem for all of the developers to do in the robotic development, because if you are looking for like the good performance for the model, like good performance for the robot to do like the accurate movement or the actions, you need to optimize the data collection process. Like you need to get more data, and you also need to get the good data set. And I think for that, we also have a highlight about the keynote from the Jim Fan. He introduced about the Groot architecture in the session of I think the name is Introduction to the Humanoid Robot Development. So it's insightful seminars, like he introduced how to build humanoid robots and introduce the latest Groot N1 models there. And he mentioned like 3 computers to support the physical AI strategy to build up the Groot architecture. So I think, can we change to the previous 2 image? Yeah, this one, yeah. There's like 3 computers there. So first one is the OVX computer for the simulation. It's like the powerhouse for the simulating teleoperation scenarios and run the Isaac scene that the GPU accelerated to generate like tokens to be used for the real-world task. And once you generate these tokens, then you can use the DGX computers to learn from the tokens and handle like the large-scale deep learning workloads. I think it will feed trillions of these tokens into the latest Groot N1 foundational models. And finally, you can deploy on a low-cost, high-efficiency, low-energy consumption computer device like the AGX computers. We also provide the AGX, the Jetson AGX development kit, and also the carrier board in our C Studio Bazaar. And I think for this computer, it will enable the robots to run the Groot N1 model and perform the complex actions like grasping and manipulation, all while being energy efficiency and is enough for development in real-world environments.
I think that's an interesting thing. So Groot is a bridge tool, like connecting the simulation and a training simulation and deploy.
Yeah.
So that is so the developers it's through this Groot Isaac the whole pipeline and then connecting the key steps for building up actually any robot.
Yeah. It's a bridge to like sim to real and real to sim. And I think now it's quite clear to see that how the seamless integration of the simulation, learning, and deployment. So with this robot structure, he also introduced the detailed architecture of Groot N1. It's like the only 2 billion open humanoid foundation model, which is a very small model, good for the limited resource computers. And as Eli mentioned before, the fed data should be like integrated with various tabs to get a better perception. So for N1, you got 2 types of tokens taken into the model. So the first one should be the visual data. It's the egocentric view of the robot from its camera. And also another one is the language instruction, like the LLM. And for the output token, you should take the motor action tokens. So normally we consume that the robot should output a series of motor actions like lifting, moving, grabbing, these kind of actions, but it's actually not. The actual output should be like the curve picture, like a bunch of floating numbers. So these motors can complete the task. So what the model actually needs to learn is how to output these curves instead of the specific the action instructions. And to learn this strategy, you also need 2 powerful tools that we've been very familiar with multimodal domain. So the first one is LLM. It generates the discrete values of text, symbols to make it sequential so that it's good for reasoning. And then another model should be like called the diffusion, which can generate continuous values like the pixels and also audio waves. It generates the whole image, like the whole bunch of pixels in the parallel. So I think we can show the Groot N1 video there, to see what's the architecture for that. Yeah, so during the humanoid robot workflow, we can use the vision language model with the tokens and autoregressive model to do the vision language reasoning to understand the scene and the instructions. Then for the actions, we can encode the robot states and put the noisy action tokens into the diffusion so that we can take a series of diffusion steps to become the actual motor action output. Yeah. Finally, it should be like the humanoid robot actions. And then, yeah, change to the next one. Yeah, and change to the next one. 下一个. Yeah. So moreover, I think the highlights for the N1 model is cross embodiment. It's trained with diverse robot factors like the single robot arm with like this one with the gripper, or like the two arms with hands, two arms with grippers, and even like the low-cost robot arm kit from Hugging Face robot.
Yeah. So we can get started from the with Groot in the Isaac GROOT page, and you can directly download Isaac GROOT N1 model or experience the synthetic data. So if you already have the any robot arm, and you can start it to integrate using the GROOT model and then to deploy down the robot arms.
Yeah, as we mentioned before, the Groot N1 model has already been verified in our hackathon. One of the team in our hackathon, this team, they have already verified the model on the robot arm kit. So we'll go through the hackathon later, but right now let's wrap up everything from GTC. We can show guys this year what we show in our booth.
Right, exactly. So this year we bring many things to our GTC booth.
Maybe
booth,
you guys, you can check out the picture. Like it's really crowded.
Where we have a small booth, but we squeezed all of our products for our robotic team, the product line. Also, we bring our new products. We will show up later in this live stream. That is our this year roadmap. And we have 3 demos. You can see here in this front desk, we have the robot SO100 arm, and on the back, this is for the robot. We want to show the imitation learning, and on the back we have a robot arm provided by HackSmooth, our partner, providing in our last video live stream for reComputer Mini. We also use their chassis and also using their arm for play ping pong. Right, and also we have here we have another demo. Is provided by our HiTalk, a company in Guangzhou. They are providing models, and also they have open sources bipedal robots, and then can deploy powered by reinforcement learning. So it's open source and the low cost bipedal robots. Yeah. So for these 3 demos, we want to show you can start the advanced building up the robots from the very low cost robot arm within $200, and you can you can also using the Isaac Sim, the simulate the real to sim, sim to real, this using the robot arm, and also if you want to experience a humanoid or the bipedal as seed, you can find the examples, tutorials, and also reference design.
Yeah, and all of these 3 demos, they are powered by our NVIDIA GTC Array, like the Array Nano or Array X.
Yeah, so therefore for the robot arm, you can choose. You can just for the robot arm, you can just choose Array Nano or Array X. Even for bipedal, it's using Array X. For the humanoid, and also for the AMRs with the complex perception, and then we will recommend the AGX Array. So it depends on your need, depends on how you design the system, and then you can find SC Studio. Yeah, so I want to show, I want to mention our roadmap. I will introduce the new products. Okay, so here, so previously our Jetson, our AI robotics team we have reComputer, and if we go back to the 2022 or when we started the Jetson, it's starting from the Jetson Nano and Xavier NX and the Jetson Orin. So now all of our mainstream products are Jetson Orin. But previously our best seller is the reComputer Classic. That is with the it's for both development and also commercially deployment. So it equips, it's a similar design of the Orin Nano and even the Jetson Xavier NX dev kit with the USB, HDMI, those necessary interfaces for quickly get into the Edge AI. And then we have the Vision AI products for that, including the reComputer Industrial, because it comes with the dual Ethernet and also it's a fanless design. But it also has some industrial interfaces to for people can deploy the Vision AI in the space of the like factory manufacturing to connect it to the legacy machines. And then we also have the restorable industrial, restorable with the 4 gig that is designed for AR and VR. As with a 4 PASE for using the video analytics system. And so this year is obviously we get more products for robotics. The first one, the last year, the end of the last year, we got is the reComputer Mini. The Mini is the most compact products. That is the most compact device we released so far. It is support Orin NX and Orin Nano, and it comes with CAN interface with the multiple USB. So all the interfaces we can think about for robot development, because it's very compact and it's active fan, so it can be squeezed, it can be integrated into the body of the robot. And I want to mention highlight the 2 other new members joined our ReSync family. The one is reComputer Super. The reComputer Super and reComputer Robotics. So they're using our new design. I think they are more stylish, and also they support Jetson Super mode. It can only for both Orin Nano and Orin NX. So all of our products will support Orin Nano Super mode, but it's not everyone for Orin NX Super mode, because Orin NX for enable Super mode, it needs the power consumption is 40 watts. So the original design cannot take this high power consumption. And so for the Jetson Robotics series and also Super series, they support both Orin NX Super mode and unleash up to 157 tops. Yeah, so let's go check out these 2 products in very detail.
Yeah. So these 2 products is not already released yet, but we are going to launch it. Like the Super is going to launch in this month, and the robotics is going to launch during this Q2.
Let's take a look. The first one is gonna be released in April. With the reComputer Super. So this is the robotics.
This is
robotics. Yeah. So I want to compare compare it with the reComputer. So we upgraded from the reComputer. The first thing is the first difference is the lead. So previously actually, reComputer, the Classic, can be for development and also commercially deployed. But we have customer feedback. It looks not very robust, but actually it has massive deployment across industries. So this one is with the with screws, with screws, and you cannot open that. And also because we want this box can cover the 40 watts of the power consumption, especially when you run the RNX. So the heatsink must be redesigned. So it comes with both heatsink and also the active fan, and then can make that can be run in the from up to 55 Celsius temperature.
Okay.
Yeah. So and then let's go check the
interfaces.
The interfaces. Actually, they are still compact designs. They are almost the same. The interfaces is almost the same, but more. So first thing so
I think they already keep the same USB ports, and also but there's another difference that they add one more Ethernet based on the reComputer Classic. So for the Super one, you got 2 Ethernets, and also you got a mini PCIe for the LG module integrated on it. So that's like the huge difference. And besides that, the reComputer Super is already flashed with the Jetpack 6.2. So you have the Super mode on device directly. But for the other products, like the reComputer Classic or the reComputer Mini, you need to like reflash the newest Jetpack by yourself. But we already provide the BSP package for you.
Yeah. So it already comes with Jetpack 60.2.
Yes.
For the reComputer Classic right now, it's still it's pre-flashed the Jetpack 1.5.13. But we still provide the BSP. You can install by yourself.
Yeah.
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 Okay.
And then we can check the robotics series.
Yeah. So the robotics where I get this very fresh EVT from our R&D. And yeah, it's very fresh EVT. It's not, I would say it is not 100% confirmed yet. This will be the final product we're gonna bring. But our device and boards are open source. We want to give every people a first glimpse and let us know if this design is your ideal preference. So this is the inside, the bare boards, and this is the box for that. So it is still using the fan plus
the heatsink enclosure.
Yes, to make sure it can stable around in the 55 Celsius. For Super actually it's 60. It's 60, and for the robotics. For robotics is the 55.
Okay.
And for so we can see the interfaces here. So compare with the Super, why we say why it is the robotics. Because so actually this one is we take the reference from the reComputer Mini, but the Mini, the box is too small to cover to handle the RNX Super mode. So it has to become bigger, and so we keep the design of the Mini of the 2 door can. One can, the can 0 is from the XT30, and it can also power the motors, and also we get GST as the can 1, and we keep the door Ethernet, and you can connect with the you can use for the internet, or you can use that mostly is using for connecting with the LiDAR and also some cameras, and also USB, you can also connecting with the cameras and LiDAR. And also for the cameras, if you want to connect with the MIPI or GMSL, we have this one GMSL is 4 LAN to connect up to the 4 GMSL cameras. Yeah, it's using for the GMSL. It is using the P2P, the B2B expansion boards interfaces. And why we design this as a modular is because for this expansion, you can also customize for us, or you want to going back to us to say you want to make it one board, we can make that with the customization. And another thing I want to point out, actually, we get this board is a power board it's also using the B2B, and it comes with the XT with the dual CAN. Yeah.
Well, this one is also separated.
It's separated.
Okay.
Yes, and also people can redesign this, and also actually for this one we get the Wi-Fi. And also the SSD, and also the 5G.
Okay.
Yeah, SIM card. So mostly it's just more functionalities than reComputer Super. Yeah.
Yeah, that's great.
Yeah. Okay, so this one we hope we can release that by
maybe May or June.
June.
Early June.
Yeah, but this one is April. Yeah, this month.
Okay.
Yeah, for reComputer Super. Both of them will support RNX Super mode, and then you can unleash the power for your robotics design. Yeah. We can also. It is also available now for. Actually, we have this data sheet. We have the data sheets here, the reComputer Super series, and also I will send this in the link in the live stream, and it listed all of the interfaces, and this is the robotics. Yeah. Oh, by the way, I forgot to mention. So for reComputer robotics, it's wide. It's the wide voltage. It's the same as the reComputer Mini. It supports up to 54.
Yeah,
so that is mainly designed for the robotics. Yeah.
I think it can directly link to the 48 watts, like the battery.
Yeah.
Power input. And then I think we can go directly to the hackathon part. Right after GTC, we also host an Embodied AI hackathon in Mountain View. This is also like the first time that we bring the extreme developing project within 36 hours to meet our lovely community members who's got fresh but crazy ideas to create the team to hack together. And we appreciate everyone's attention and enthusiasm to join. We've seen so many interesting applications like pick-and-place objects, tried with different models, and expand the form factors with the creativity.
Yes, this hackathon is we co-host with Hackster, the very large and very popular the open source and developer community. And we also have NVIDIA joining us, and also Hugging Face, and OpenCV joining us as the judge, and Open Robotics. So and also we hosted in the Circle Lounge as a co-host of the co-organizer for the event. So I truly and heartfelt super thanks to the community, especially Circle Lounge. Circle Lounge, we found is a very good makerspace plus incubator in the Bay Area. They have two spaces. One is in the Oakland, California, and another one in the Mountain View. So they have they're very specifically help their members for robot development. They have very good robot company there. As an incubator. So I would highly recommend you can go check out Circle Lounge if you are in the Bay Area. So let's go over, we have the video about the recap of the hackathon, right?
Yeah, we can check out the exciting moments at the beginning.
Yeah.
Hi everyone, we're the fire-breathing rubber duckies. Today we're gonna show what we've tried to do with 2 arms and having cameras and 3 cameras in our system. So I guess I want to ask a question to the group itself is what do you think the most important part of a robotic system is, or robotic diffusion policies are? It's calibration and good data, in my opinion. So whenever we try to calibrate the Lee robot or the steps they've given us, it's actually good for it to move in a robotic sense, but it's not good to teleop as a human, right? Because you're trying to move the arm and you're trying to grip in like this awkward position. So what we've done innovatively is we've essentially changed the way we do calibration itself, where we already rotate the calibration by 90 degrees for the gripper, so that the camera actually views down into the gripper where it's picking up. Another thing is we also added motors back into one part of the arm because we were hitting singularity. So to make sure that basically the elbow joint, so we have more traction in that one location. So that allows us to teleoperate much better and easier. The unique thing is we've trained on NVIDIA GROOT N1 and we've got the best results out of all the 3 policies. This is a model that was released 2 days ago at NVIDIA GTC. We've also trained on ACT and Pi0 models. We've deployed ACT and Groot N1 as well. Pick and place from the cup to the plate, as well as pick from the plate to the cup as well, both bimanually, and they actually wait for each other to complete. So, and both robots run one single model itself when they're completing the task.
Awesome. Well, thank you so much, everyone. And today we have an exciting thing to share with you. We are the circuit launch.
You can check the full videos in our YouTube, and also we have listed on our hackathon page with these all amazing projects. Actually, we have 5 teams, right?
There's 5 teams, and each team should contain 6 to 8 people join there and develop together. And they use the SOARM 100 robot arm kit. It contains 2 robot arms inside of it, so you can check out on the table. There's a leader arm and also a follower arm. And for this project, these contestants, they should complete the first step, which is the teleoperation. So you need to, at the beginning, you should assemble all of the hardware and then do the calibration. And finally, if you want to see the complete successful part for this process, you need to do the teleoperation. You need to operate with the leader arm to do one action, and then the follower arm should do the same action by itself. So this one is successfully completed. And then the second part is the data collection. For this hackathon, I think they collect 20 episodes at least. And then each episode, it contains 50 to 80 images for each round. So I think that should be the basic level enough. But if you want to optimize the model better, you need to collect more data for that. And after the data collection, you need to validate the policy. You need to use trainable ACT or diffusion policy or Pi0 or the latest Groot N1 model. And finally, after the training and deployment, the follow arm can do pick a apple or pick a pen, this kind of action by itself.
Yeah. So for each task, they get 50 episodes for each task.
Yeah.
Actually, I think the most consuming part is data collection. We have every time our hackathons, we get participants stay up to after 11 p.m. For the data collection and the training, because they get usually for the first task. Usually it's not ideal. They gotta retrain. So, but if you get graphic cards resources for at least the units, we recommend are 3060 and above. Using 3060, it takes 6 hours, and the 4090 it takes 2 hours. If you're using A100, H100, it will take half hours for your reference.
Yeah.
Yeah. And let's go. And for this hackathon, the Bay Area, super thanks to Hackster and co-organize this event and make this very beautiful page, and for including all the detailed tutorials, and also for each projects for 5 teams. So for example, first congrats to for their team, fire breathing rubber duckies. They're running SO100 on Isaac GROOT N1, and their projects are bi-manual robot arm. In total, there are 4 arms. So here they included their why this project, and what parts they've been using, and they have uploaded their datasets to the Hugging Face already. And so each and also thanks to other 4 teams. So you can check in the Hackster page and to get their tutorial and see their very cool demos.
We also have a Embodied AI hackathon landing page, so you can see all of the hackathon that we've already hosted since December 2024.
Yeah.
There are like 4 or 5 hackathons there. We have the recap video for that. You can see all of the moments and all of the projects, the demos that the group have already created.
Yeah, we have already went through many cities: Shanghai, Shenzhen, Wuhan, Mountain View, and our next one we'll go to Paris. We'll get a Le Hackathon.
Yeah.
So
the France pronunciation.
Yeah, I hope I'm real correct. Yeah, so yeah, we're going to Paris in May. In May 6 and 7, got a 2 days hackathon at GOSIM event, GOSIM AI 2025. GOSIM AI Paris, they are a open source event. So this conference will be hosted in the Station F, the largest incubator space in Paris, and also they have different track for the open source, including AI model, infrastructure, apps, embodied AI, where being included in the embodied AI, and they have PyTorch AI Paris Day. So yeah, it will be very exciting. So if you are in Paris, join us and see you in the GOSIM AI 2025, and focus on the open source projects and community.
So based on all of the hackathons that we host right now, if you already joined one of our hackathons and you had a great experience, so why not take it further? We love to have you become a seed ranger and help to bring these events to your local community. So as a ranger, you can host workshops or these hackathons, or you can bring up new ideas of the new events, and to support the fellow participants with technical guidance.
Yeah, so if you're interested in co-organize the other hackathons based on the robot, SO100 ARM, or other cool open source embodied AI projects, because we want to bring these events locally and worldwide. So if you're familiar with this project, you're already hands-on, your experience, you want to be a mentor or an organizer, please contact us at edgeai@c.cc, and so we want to reach out and see how can we collaborate together.
Yeah.
Okay, so
on the landing page at the bottom, we also have a Discord channel, so you can also join this Discord channel and discuss more ideas and new topics with us.
Yeah, join our Discord, and so we will update everything there. Yeah. And we also have another page. I want to quickly give people a look. So at Seed, our AI robotics team, what we are focused on is first, we design and produce the hardware, the Jetson devices and the boards for use as a brain for different robotics. But we are very active. We're active in the different open source projects and tutorials, examples you may already find. We get it in our wiki. And so we always stay up with the latest, like Cosmos, Isaac GROOT N1, and also other robots research program in the different by the different research organizations. So check out everything at studio.com/AI robotics. And yeah, so we get tutorials, and we get so for the robot right now, we get everything here. You can start build your own. And we also previously we have the live stream with K-Scale Labs. They're doing the open source humanoid robots, the big one and also the small one. We have live stream, and they have open source everything, including their hardware and software SDK. And also we get the products. So everything you can check in this landing page.
Yeah, I think you can check the link in the comment. We've already sent the link there, and you can see all of the components and all of the content later.
Yeah.
Yeah, I think that's the wrap up today.
Yeah.
Hope you guys enjoy it. We have so many exciting stories and exciting recap to share with you.
Yeah. I hope you can also feel a little bit our excitement what we went through at the GTC. The new technology and also the hackathons, how we engage with the developer community. We also keep going in the next.
Yeah. So hope to see you in next GTC 2026.
Yeah, of course. Yeah.
All right. Thank you. Thank you for joining. See you soon.
Oh, do we? But I want to end, but I want to know, do we need to pick some questions? I think we forgot. Okay, let's try to answer like one question.
Yeah, just pick one or two.
Yeah, I forgot that part. So one thing.
Any plans in India? Right now.
Yeah, we want to host that with Ranger. Yeah. I think there is a question said, Tori Eric Hartman from Iowa. So software can send out commands to a motor controller to the servo or motors. Yes. So we can. I think I can send a video. Yes, exactly. We already have the examples for using our reComputer mini and tested robotics to control the door models. We will send that demo in our social media later and our Discord. I want to show the video, but I don't know how to get it to the OBS now.
Yeah, we'll share the video in LinkedIn or Twitter.
Yeah. Another question is is asking, do we have plans to sell motors? We are testing right now, and so we are testing a couple of different models, and we want to. We're also building up the documentation. So the first, it's not confirmed yet. We will bring that up, but what we can make sure is we will give the documentations and examples now, and also let customer know where how to buy them with our partners.
Mm-hmm.
Yeah. So stay tuned, and so we will soon release some models selection guide.
Yeah, we'll share some compatibility information or like the tutorial first, and then
Right. So all of the not only models, but all the sensors that is always validated by our team first, and then we wrap up the getting started. Yeah.
Yeah.
Okay. Okay, so that's it. I hope I covered everything. And so if you have any questions, emails, but the best way is join our Discord group. We can live chat there.
Mm-hmm. All right.
Okay, thank you.
Thank you. Have a nice day. Bye.
Happy Friday.